A really interesting question here about tangents to circles, and later on we're going to have two circles and we're going to be finding the lines that are tangent to both of them. But let's get cracking. At the start it says we've got a circle with center AB and radius R. So let me write that down. It's going to be x minus a squared plus y minus b squared equals r squared. That's our general equation of a circle. And then there's also a line with equation y equals mx plus c. And we're asked to find where they intersect. In fact, we're asked to show that this equation is satisfied. So that's what we're aiming for. Okay, so they intersect when the x values are the same on both curves, something like this, and the y values are the same. So I can replace the y in the first equation by the y in the second equation, or mx plus c. X minus a squared plus mx plus c minus b squared equals r squared. And in the final answer, it's clearly been written as a quadratic in x squared, x, and then the constant term. So let's first of all expand. We're going to get x squared minus 2ax plus a squared. Plus, I'm going to be a little bit more careful with this one because there's three terms in it. So I'm going to get m squared, x squared, plus mcx. I'm going to get another mcx there. So plus 2mcx. And then minus mbx. And then I get another one there. So minus 2mbx. And then onto the c's, I've dealt with some of it. I'm going to get plus c squared. And then minus cb. I'm going to get another minus cb there. So minus 2cb. That is 9 terms, I believe. 3, 4, 5, 6, 7, 8. Or if I missed one. I forgot about the b plus b squared. Okay, that's everything. And that is equal to r squared. Apologies, I couldn't quite fit it all in. So let's collect terms. I've got m squared plus 1 x squared from here. I've got minus 2ax. I've got lots of x terms here. So I'll write it as plus 2. I'll factorize the 2 out. And then it'll be minus. Actually, I can factorize the x out as well. But I'll put that at the end. So minus a plus mc minus mb x. That is all of those x terms. And then plus a squared plus c squared minus 2cb plus b squared minus r squared equals 0. Let's just check in with what we're actually trying to get to. We're sorted with the x squared term. Just need to manipulate the x term a little bit. I can see I've got this here has been factorized, and actually that is that. C minus b squared is there. So I'm nearly there. M squared plus 1 x squared. Okay, I need to change this to a minus, like they have in the answer. So that will give me a positive a. And then I will get a minus mc plus mb, which I can then factorize out the m for. So I think I can go straight to this now. That is definitely the same because I'm going to get plus mc overall. I'm going to get minus mb x plus c minus b squared. I showed where that came from. Oh, sorry, I forgot about the a squared. That first. A squared plus c minus b squared minus r squared equals 0 as required. Good. So part B says that Given that L is a tangent to C, show that this is true. Okay, in part one, I had my circle and I showed a line going through it, but actually we're now being told it's just going to glance off. Actually, that one's missing it. Just going to glance off like that. So it's going to be one point of intersection. We've got a quadratic. It's got one repeated solution. This is a discriminant question. We can investigate b squared minus 4ac equaling 0. I've made them capital letters to distinguish from the lowercase b and a in the first and c in the first question because they were different things. All right, let's give this a go. So I'm going to square. This is my b. If I square that, the negative just goes. I'm going to get 4 times a minus m c minus b all squared minus 4 times m squared plus 1 and then times by c a squared plus c minus b squared minus r squared, and all of that is equal to 0. I'm going to divide through by 4 to get rid of these and then expand the brackets. A squared plus m squared c minus b squared minus 2a m c minus b, that's that first bracket expanded, minus a squared m squared plus 1 plus c minus b squared m squared plus 1 minus, oh wait, I just noticed there's a, sorry, that should have been a minus because there's a negative here. Need to be more careful. A negative and a negative there, then that one will become a positive. So that should become a minus, and this one's plus r squared times m squared plus 1 equals 0. Right, now some things do cancel, and I'm going to go ahead and cancel them now. The a squared here is going to cancel with this minus a squared that comes from me doing minus a squared times 1. Is there anything else that clearly cancels? Okay, I can see that also I've got m squared times c minus b squared. That's going to cancel with this m squared times c minus b squared. So I'll just tidy this up. And remember, I'm trying to get c. So minus 2am times c minus b minus a squared m squared minus c minus b squared plus r squared m squared plus r squared is equal to 0. Right, now what I actually spot here is that I've got a quadratic in c minus b squared. Or sorry, in c minus b. So just a moment, I'm going to let u equal c minus b to make life a little bit easier. And I'm going to get everything, I'm going to basically swap the signs for everything. In fact, I can just do it straight here. This can become a plus, plus, plus. This becomes a minus and a minus. So that means that u squared plus 2amu plus a squared m squared minus, I'm actually going to, I feel like I shouldn't have expanded that bracket. I'm going to rewrite it as r squared m squared plus 1, not least because I can see this in the answer. So that is going to equal 0. Okay, and then I can solve this quadratic. I could use the quadratic formula, but I'm actually going to complete the square. Quite often just an underrated skill for when you're dealing with a quadratic. It can be a bit quicker than using the quadratic formula. So u plus, then I have this term to give me am squared. That will give me u squared plus 2amu plus a squared m squared. So I need to minus a squared m squared, which then cancels with this a squared m squared. Perfect. And then I'm going to be minusing this, so I can now set it, I can add it to both sides and set it equal to r squared m squared plus 1. And that means that u plus am is going to be the square root of the right-hand side, or plus or minus r times m squared plus 1. Oh, square rooted. So I'm do you know what? Let me do this in stages. I'm square rooting r squared times m squared plus 1. Now I'm going to rewrite it. I just found it was a bit easier when I had it as u, but I've got to write it as c minus b again. So c minus b plus am is equal to plus or minus r times the square root of m squared plus 1. And that means c is going to equal, just take a little glance at the answer, b minus ma plus or minus r times the square root of m squared plus 1 as required. Nice, well done so far. So far we've derived two formulae that are both very general. The first one true for any intersection of a general circle and a general straight line. The second one true when that straight line is a tangent. It simplifies greatly for the relationship. Okay, and now we're going to do some applications, particularly part D, which is related to a tangent. First of all, we're given two circles, C1 and C2, and we're asked to find the equation of any lines that are both normal to them, justifying our answer. Oops, sorry. Okay, well, I honestly think a good idea here is to get a sketch down, and also we're going to need to find the centers and radii. So let's complete the square. The first one's okay. It's going to be x squared plus y squared is equal to 4 squared. So center 0, 0, radius is equal to 4. Second one, a little bit more involved. So that was C1, C2, x minus 10 squared gets me x squared minus 20x, but I need to minus 100, plus y minus 5 all squared, minus 25, plus 89 is equal to 0. Minus 100 minus 25 is minus 125. Add that onto the other side, or onto both sides, minus the 89, 125 minus 89 is 36. So we get 6 squared. Center 10, 5, radius equals 6. I can now sketch these. It's not to be a perfect drawing, just an idea of what is going on. Okay, I can cheat a little bit because I've got a circle drawing tool, but it's, it's not essential. Okay, the first one then, radius of 4. Let's put it like that. So this is going to be 4 here and minus 4. Then the second one, center 10, 5. So maybe up here. Now there's two things to spot. It's going to end up going below the axis. And if the center is at 10 here, then that means it's going to get to the point x equals 4, because 10 minus 6 is 4. It's gonna be on that same vertical line. So if you can realize that at this point, then that is really good. Okay, so something like that. They just are in line at that point there. So for the normal, a normal is a line that is perpendicular to a tangent, and the normal is always at right angles. So that would be, for example, a tangent of the red circle. The normal's in at right angles to it, but it's also got to be at right angles to the green circle, which means I'm interested in drawing a line that's like this. Basically, any line that goes to the edge of a circle will be a normal because it will then be at 90 degrees to a tangent. That's the definition. So I'm joining them up, and both parts of the purple line you can see are going to the center of each circle, but you join the centers together, and that is a normal that is a normal to both C1 and C2. So I'm trying to say here. Okay, well we can quickly see the y-intercept is 0 because it goes through C1. We're going along 10 and up 5. Therefore, for the normal, the gradient is going to be 5 over 10, or a half. And that gives us the equation y equals a half x. That is the one normal for this. I've justified it in words, but I'm just going to write, well, actually, I'm going to take it from the answers. So, got to write something along the lines of the normals must pass through the center. So, there's only one common normal passing through both centers, and then we can calculate it. You could use differentiation. You could find the gradient of each circle, but I mean, that is just completely unnecessary when you can do it this quickly, so I'm not even going to go there. You do, and hopefully already do, have to look at the mark scheme for questions like this. And the fact that there's only 3 marks tells you it's not going to be that involved. In fact, it's very quick once you've got the sketch. But of course, the marks involved completing the square and so on. So when you get to part D and it's 11 marks, this is telling us it's going to be a lot more involved. We're going to now find the equations of all the lines that are tangent to both C1 and C2. So let me bring this sketch down, but now instead of normals, we're looking at tangents. We can get some insight just from the sketch though straight away. So I'm not gonna use straight line tool here because it won't quite fit in, but I can see this is gonna be a tangent to both. And then there's also gonna be one going along here. It's not necessarily going to hit the bottom of the red and green circles, by the way. It's just a sketch to illustrate that there will be a tangent there. Okay, I can't have one sort of going this way because that's going to intersect it, but I could have one going like that. So I've got 3 so far, and there is actually one more, and this is why I emphasize the importance of a good sketch at the beginning. I said that they both touch that line, x equals 4. So that is our first solution. X equals 4 is a tangent to both. So we're going to get 4 solutions here. And that one is very quick. Easy to miss if you don't draw your sketch well as well. Now, do not try and do this from scratch. Remember, part B, all the way up here, we found a relationship between C, B, M, A, and R. And don't forget, A and B were to do with the center of the circle, and R was the radius. So we can put them in the 2 circles that we have. A long time deriving that formula. So for C1, A is equal to B, which is equal to 0, and R is equal to 4. We had x squared plus y squared was 4 squared. For C2, the center was 10, 5. So A is equal to 10, B is equal to 5, and it was equal to 6 squared, so R is equal to 6. And then we're interested in, so C is going to be the same for both, the tangent, it's a tangent to both. So C is going to be the same for both. And therefore I can write down for my first circle that, well, this is just going to become 0. So plus or minus 4 times the square root of m squared. Actually, do you know what? I'm going to take my time with this. So for C1, C equals plus or minus that. For C2, the same C is going to equal 5 minus 10m plus or minus 6 times m squared plus 1. Okay, now I can set them equal, but I've actually got four cases to consider. I've got when the first one is positive or negative, and then when the second one is positive or negative. And some of the equations are going to be similar, but you'll see in a minute why we have to be careful here. So case one, right, let's deal with them both being positive. I've got like terms, so I can then rearrange that to 2 lots of square root of m squared plus 1 is equal to 10m minus 5. Okay, I can square both sides now. The thing I'm going to say is when you start squaring both sides of an equation, you can actually introduce solutions that don't exist. Sometimes this comes up quite early on in AEA. I've seen it as question ones. You've always got to bear that in mind. We can't just solve this. We need to then check back and see that it actually works, because you could have, for example, that x is equal to 3. I mean, this is a very trivial example. You could square it to give x squared equals 9, and then you get x equals plus or minus 3. So is minus 3 also a solution of x equals 3? Of course it's not, but squaring it has produced that solution. And it happens for more complicated situations like we have here. So let's square it though, to get rid of that square root. I'm going to get 4 times m squared plus 1, so 4m squared plus 4. And then I'm squaring 10m minus 5. That's going to give me 100m squared minus 50m, so minus 100m plus 25. Therefore, 96m squared minus 100m plus 21 equals 0. Turns out this does factorize, but I took one look at it and I thought I do not want to try and factorize that with a coefficient of 96 here. And 21, we've got a few choices, probably 3 and 7, but I don't know that. Could be 1 and 21. So I started completing the square actually, and I thought this looks messy. So I did decide to go to the quadratic formula, and that's what I'm going to use here. I'm not saying it's the best way, but it worked out. So I've got minus b plus or minus b squared. I'm just going to write 100 squared here. Minus 4 times 96 times 21 square rooted all over 2 times 96. Now, I definitely want to make our life as easy as possible here. And there is a common factor of 4 squared that goes into 100 squared. In fact, it's going to be 4 squared times 25 squared. And there's a common factor of 4 squared here as well, because 96 is actually 24 times 4. So it's 25 squared minus 24 times 21. This will make life a little bit easier. And then I'm dividing by 2 times 96. I'll keep that as it is for the moment. Right, well, I think it's 25 squared. I actually know that one. It's worth knowing a few square numbers like this. It's 625 because it's 5 to the power 4. 25 times 21, I don't know, but I do know that 24 times 20 is going to be 480. So if I add another 24, I'm going to get 504. And then 625 minus 504 is 121. And that is a clue that's going to factorize because this is a square number. So 100 plus or minus the square root of 4 squared is 4. The square root of 121 is 11. Over 2 times 4 times 24 as we had before. The 4 cancels with this one and with this, leaving us finally either 36 over 48 or 14 over 48. There's a common factor of 12 here, 3 over 4, or we can cancel this down to 7 over 24. But we just need to check back that these actually work. So this is why I've got them separate. I'm gonna work out C in each case, and I need them to be the same in each case. Because if they're not, then it's not actually a valid solution. It's a spurious solution that I've introduced through squaring. Okay, so if M is equal to 3/4, then let's look at C1. C is going to be plus or minus 4 times the square root of 9 over 16 plus 1, which I can write as 16 over 16. Sorry, when I say plus or minus, of course, we're considering the positive one here. And that is going to be 4 times 25 over 16 square rooted, so 5 over 4, which gives 5. Let's look at C2, check that we get the same thing. And yes, you do have to be this careful. C is equal to 5 minus 10 times 3/4. I've already, plus 6 times, I've already worked out this thing here. It was 5 over 4. Now both of these are 30 minus 30 over 4 and 30 over 4, so they cancel, leaving me 5. And that is going to be another solution then, because I get 5 for both. Y equals 3/4 x plus 5 is my second tangent. Now let's check 7 over 24. Remember, this is only case 1, but some of the other cases are going to be a lot quicker. Okay, so let me just check that. 7 over 24. Right, C1. Going to get C equals plus, not plus or minus, just the plus, 4 times the square root of 7 squared over 24 squared. And I'm not going to square them for the moment. You'll see why in a second. And then plus 1 or 24 squared over 24 squared. So I can add these two fractions, and in the question it tells you the Pythagorean triple, 7 squared plus 24 squared is 25 squared. I don't need to work that out. Giving me an answer of 4 times 25 over 24. Sorry, I've written so much that I've just started getting lag. Apologies. The 4 partially cancels, leaving me 25 over 6. Then C2 gives us C equals 5 minus 10 times 7 over 24 plus 6 times that square root, which remember was 25 over 24. Remember, I'm trying to see if it's equal to 25 over 6. So I've got 5, I've got minus 70 plus 150, so it's going to be plus 80 over 24. And this is clearly too big because 25 over 6 is 4 and a bit. So I'm gonna reject it already. I don't need to actually work out what it is. Right, remember that was just case one. So we did all of that for one solution. But the next solution we're going to get is actually going to be a lot quicker because what we can do is go onto a new page here, so it's going to run a little bit faster now. I can just take the negatives of both. And this will still lead us to 2 times m squared plus 1 is equal to 5 minus 10m. This time it's almost exactly the same, but I've got the opposite here. And so this is why I can see how spurious solutions are occurring because I've got almost the same thing, but the negative. So there's no way that all the solutions can be valid. If we follow through on the solution, just like we did before, we'll get m equal to 3/4. And this time, if you sub that back in, you would reject it because remember, it worked when they were positive. But there's no way that it's going to work this time. I mean, you can follow through the maths, but we've already got um, yeah, well, I mean, I guess you could get another solution for 3/4 in theory, even though we saw from the diagram that none of the tangents looked parallel. But if you follow through with it, you'll see that you reject it. And the other one is 7 over 24. We rejected that for case one, but let's see what happens case two. So for C1, we're going to get that C is minus 4, and it was 5 over 4. So minus, oh, sorry, that was for 3/4. I'm getting this mixed up. Minus 25 over 6, because it was 25 over 6 the first time. Okay, then for C2 last time, we didn't get the same thing. Let's see what happens this time. So C is going to be 5 minus 10 times 7 over 24 minus 6 times, and when we put it into here, we got 25 over 24. I'm going to put all over 24, so this will be 120 over 24 minus 70 over 24 minus 150 over 24, which becomes minus 100 over 24. Divide through by 4 gives minus 25 over 6. So this works. And the third solution is therefore y equals 7 over 24x minus 25 over 6. Brilliant. So case 3 is going to be when one of them is positive and one of them is negative. I think I'll make the first one positive. No, I'll make the first one negative. Minus 4 times the square root of m squared plus 1 is equal to 5 minus 10m plus 6 times the square root of m squared plus 1. That leads to 10 times m squared plus 1 equaling 10m minus 5. Similar sort of setup. Actually works out really nicely now when you square it because you get 100 m squared plus 100. And you get 100, when you square the right-hand side, 100m squared minus 100m plus 25, just like before. And it does work out nicer. So you might, like in hindsight, it's easy to deal with case 3 first, but I didn't think to do that. I just thought, right, let's make them both positive, but we don't have a quadratic. In fact, we get 100m is equal to minus 75, therefore m is minus 3/4. Put this back in. So for C1, it's going to work out in the same way that when we put in 3/4, actually. You might remember it. Sorry, the working is somewhere else. But we get C equals, remember I made this one minus, we get C equals minus 5 because this thing here is 5/4. And then for C2, when you work through on it, I'm actually not going to do it. I think we get C equals to 20. So we're actually going to reject case 3 entirely, which leads us to case 4. And I just swap the signs around. So that that one is now, sorry, I think I forgot the negative. That one is now positive, and this one becomes negative. I actually get the same solution because I'm going to get 10 lots of it equal to this. It will all cancel out in the same way when I square it. M is equal to minus 3/4. But I hope I'm not rushing it. This video has been very long. Okay, this time for C1, I'm going to get C equal to 5 again because it's positive. Let's check C2. I get C equal to 5 minus 10 times minus 3/4. That's going to become positive. Minus 6 times what becomes 5/4. This is 30/4. This is minus 30/4. It all works out. And therefore, our fourth and final solution is y equals minus 3/4 x plus 5. Okay, that is it. The only thing I'm going to do, just for completeness, is come back to our original sketch, well, the second sketch with the tangents, and I'm going to try and identify which is which. Let's see if I can do this. So x equals 4. That was our first solution. Okay, I've got one with a negative gradient, so that's going to be quite easy to find. This one here, y equals minus 3/4 x plus 5. And you can even see it going through the same point as another one. This one here, this purple line here, that's therefore got to be y equals 3/4 x plus 5. Sorry, I'm back on the original page and computers can't deal with it. Okay, that leaves us one here, and that is our y equals 7/24, very shallow gradient comparison to the others, x minus 25/6. Yeah, another incredible question on the Advanced Extension Award. We've done some math to generate this equation. This for the condition of a tangent touching a circle with two circles. We've then found four equations in this particular case of where there are tangents to both circles at the same time. Four equations. This one a little bit hidden, which you don't get from the equation. Because remember the gradient's not defined when x is equal to 4. So you have to do that by observation. The rest of them come through being very careful, working through it. And I do really recommend being careful. Um, it's quite hard to do this electronically because like obviously all my working is just stretching so far that I kind of lose track of it and I can't easily get back to it. But there we go. Thanks for watching this video. Well done with this question, and I hope you enjoyed it. Brilliant. Keep doing maths, people.